All right, let's talk about LIT. A funny acronym, or not even an acronym, but this is a continuation of the stream of work that includes clip and align. Basically, what they discover here is that while clip and align work well, as a reminder, these are models that the vision language models that have these two components, the image component and text component, and they contrastively learn representations that sort of put images and the corresponding texts in the same space, and it has a bunch of nice properties. And I did a walkthrough of these papers previously, and this discovers that you can do something that actually gives you nice, that's sort of cheaper, but also turns out to work better, which is surprising and kind of interesting. So LIT stands for locked image tuning. So what this means is that instead of taking randomly initializing the image model and or the image tower they call, or the sort of the part of the model that is responsible for the image embeddings and the text tower, instead of randomly initializing those and training them contrastively on this data set that has pairs of images and text, instead they first take a pre-trained image model. So that can be, the choice of model is up to you. They use something trained on ImageNet to do image classification, and then they take this model that's trained just for image classification, and then they lock it. They don't fine-tune it anymore, and they then connect it together with the text model, and they train the text model. The text model is initialized from scratch, and then using the standard clip procedure, they do the same training, except they don't update the weights of the image model. And that obviously that's nice, because then you already have pre-trained image models, so you can just use them, and you don't have to train them further, which is cheaper and faster. You only train the text model, so that's nice. That's like, it makes sense that it's a nice efficiency improvement. What is surprising is that this works better than continuing to fine-tune the image tower. I could predict reasonably that if you take a pre-trained image model and then continue fine-tuning it, it will work better, because the data, and that's the argument they make in the paper, sort of they try to figure out why that is the case, and they have this theory that the data that's used for contrastive learning is less clean, because it's been basically scraped from the internet, from like millions of pages, and it's really big, but it's not really high quality. So some of the image pairs, like image text pairs, are not correct. um, but it allows this contrastive fine-tuning. Whereas something like ImageNet has been manually labeled and is really high quality. So if you take an image model trained on this cleaner data, it will have really strong image representations that you want to use, and you don't want to mess them up. And then you basically train an image model. You then basically just fine tune the text model to learn to sort of attach to this pre-trained image model, and that works the best. So they've done a bunch of experiments, both with like locking and unlocking different layers, pre-training and not pre-training. Um, and they found that this works best. So LU is the lit, so where the image model is pre-trained and locked, and the text model is randomly initialized and unlocked, and as we see, that works best. And there are graphs that I won't go into in detail that show that. One of the theories they have is that you can get, if you unlock the pre-trained image tower and you continue fine-tuning, your training and validation loss on the data that you trained on from that distribution, that will actually get better if you allow fine-tuning, if you unlock the image tower. But that will hurt it will hurt generalization, so it will not perform as good on data that's out of distribution. Whereas if you keep the image tower locked, that will preserve the generalization. So I guess the interpretation is that the pre-training creates an image model that generalizes well, and then we just need to fine-tune the image part the text part to make things work well. So this is it. This is basically the idea behind the whole paper. They have a bunch of experiments and a bunch of benchmarks that I won't cover in detail. I really like this paper. It's really clever and really surprising. So a very cool thing to read.